Alright guys, as promised, a quick review of completing the square to find the vertex. This seems to be the skill that gives people the most trouble, so I just wanted to go through and do a couple more examples, if I could. So I thought we might look at it like this. Let's take our first example, example 1. Why am I wearing these? I can't think of any good reason why I'm wearing those. Our first example, let's just take x squared plus 6x plus 4. Alright, so we'll call that our function. And we want to find the vertex by completing the square. So the thing we always do in this case is that we use the first two terms to pretend that it's a perfect square, and we ignore the third term completely. So we're going to look at these two terms, and we're not going to worry about that term. So the thing that you need to keep in mind, and the thing you need to know to answer any of these, is that any perfect square, so any factor that's squared, a plus b, you'll have to remember will always give you a squared plus 2ab plus b squared, just like that. So for example, if I gave you x plus 4 and we squared it, well, the a term is x, so a squared is going to be x squared. And then the second term is 2 times a times b. So in this case, 2 times x times 4. Well, 2 times x is 2x, times 4 is 8x. So I'll actually show that here. 2 times x times 4. And then the last term is always the b term squared. So 4 squared, which is, actually I'll write that as well, just this one time. And so if we were squaring x plus 4, we would get x squared plus 8x plus 16. And that would be the perfect square. Let's do one more example just to be sure. If I was squaring x plus 9, well, the first is the x term, or the a term rather, and so a squared is going to be x squared. And then 2 times a times b, 2 times x times 9. Well, 2 times 9 is 18. And the x as well, we get 18x. And then lastly, the b squared term, well, since 9 is b, b squared would be 9 squared, and 9 squared is just 81. So that's how we do a perfect square. What we have to do here is a perfect square backwards. Now the good news is, there's a couple things you can always note. The a term will always be x in these cases. In every question we do in this class, if you're trying to put an equation in vertex form, we're always going to make sure that the a term is x. And in fact, if there were a number in front of this x squared, we would factor it out first. So your a is always easy. It's always going to be x plus a number squared. So this is a squared. Therefore, a is equal to x. Easy enough, right? Now this term is 2ab. Now remember, this may seem complicated, but remember that the a term is always just x. So this is really 2x times b. I don't even have to worry about the fact that it's a. It's 2x times the b term. Every time, 2x times the b term. So to find b, we just divide the second term by 2x. So in this case, we're going to get a squared equals x, therefore a is equal to x. That's the easy one. A will always be equal to x. But the next thing to know is that 6x divided by 2x will equal b. We can always find the b term by dividing the middle term by 2x. And 6x divided by 2x is just 3. So b equals 3. Once we know that, we're going to rewrite this adding in the last term, the b squared term. So we're going to say f at x is equal to x squared. And remember, that's this term. That's the a squared term. Then we're going to add in the second term, which is still the same, plus 6x. But now we're going to add in our final term, b squared. And b, of course, is 3, so b squared would be 9. So we're going to add in 9. Now, so that I haven't changed anything, I'm also going to subtract 9. And then I'm also going to leave this plus 4 here. Some of you may be able to eyeball a shortcut here, but I'm not going to teach it that way. I'm going to teach it as the whole thing. So we add in the b squared term, but we then immediately have to subtract it back out. And we still keep the last term. And this means because I add 9 and then subtract 9, I haven't changed the equation. But now, this section is a perfect square, and we can go backwards. So instead of going from this to the expanded form, we can go from the expanded form to this form. All right? It would be x squared plus 6x plus 9. We know the a term is x. We know the b term is 3. So it's going to be x plus 3 squared. We'll replace all of this. And so we will say f of x is equal to x plus 3. And then we're going to square that. But these two terms are still here. Minus 9 plus 4. And I normally wouldn't bother to show both those steps, but there we are. And finally, we have f at x equals x plus 3 squared. And then negative 9 plus 4 totals to negative 5. And there we go. Now it is in vertex form. And then to find the vertex, we say the vertex is at the point. Well, the one in here we have to switch the sign, so negative 3. And here, it stays as it is, negative 5. The vertex is negative 3 and negative 5. And if we were going to sketch it, negative 1, 2, 3, negative 1, 2, 3, 4, 5. There's our vertex. And the leading coefficient here is positive, so this will open up. So if I had to say the range of this function, I would say the range is that y can be any real number, as an element of the real numbers, such that y is greater than or equal to negative 5. Then I put another brace bracket around that. And there we go. I'm going to do one more example for you, just quickly, just so we can all be sure we're on the same page. So another example, example 2, following the exact same steps. And this time we're going to say f of x is equal to 2x squared plus 18x plus 4. Okay, the first thing you'll notice is that unlike last time, there's a number in front of the x squared. And we are always going to factor anything out that's in front of here. Whatever the number is, we're going to factor it out. Even if it's not a greatest common factor, we're going to factor it out, though in this case it is. So we take the 2 out, and inside, 2x squared divided by 2 would just be x squared. 18x divided by 2 is going to be 9x, and 4 divided by 2 will be 2. There we go. So all we've done here is take a greatest common factor. Now, after we've taken the greatest common factor, now we are ready to complete the square. Oh, let me draw that. So let's take a look. Now, just like last time, we're going to deal with the first term and the second term, but we know that the third term isn't right, so we're going to look at these and figure out the third term. Now again, the a term, will always just be x. And the b term can be found by taking this middle term and dividing it by 2x. Because remember, the middle term should be 2ab, right? And we know that a is x, so it's 2x times b. So to find what b is, we just divide the middle term by 2x. So divide by 2x to find b. And you're going to do the same thing every time. You're just going to divide it by 2x. Well, 9x divided by 2x is equal to 4.5. Just like that. And so now we know that f at x is equal to 2. This 2 stays outside. We open a bracket and we say x squared plus 9x. And now we have to put the b squared term in. We have to put this term right here in, the last term. That may seem challenging, but we know the b value. The b value is 4.5. Now, I don't know what 4.5 squared is off the top of my head, so I'm going to put that in. I don't know if your keyboard ever does this, but my keyboard sometimes goes to Canadian mode, and I need to change it. Anyway, there we go. 4.5 squared, and the answer to that is 20.25. So x squared plus 9x plus 20.25. Now, as soon as I add 20.25, to make sure I haven't changed the equation, I have to subtract 20.25. So we do that here. And then I also need to make sure I don't ignore the 4.5 here. Or 4.25. The 2 here. All right, this number here that was to begin with. So I'm going to put plus 2 as well. And we close that bracket. Now, we're ready to remember that between here and here is the perfect square, because we have the a squared term plus the 2ab plus the middle term plus the b squared plus the last term. So we can put this into factored form by showing our perfect square. So this 2 stays out front, f of x equals 2, and now we open this. And the first thing we're going to put is our perfect square. Well, remember that the a term is always x, and that in this case the b term, which we found by dividing 9x by 2x, is 4.5. And so we put x plus 4.5, and we square it. Now that covers all 3 of these terms, so none of these numbers need to be expressed because they're all inside of this perfect square. So now we just need to put these in. Minus 20.25 plus 2. Now, that means that f at x equals 2 times x plus 4.5 squared, and this works out to minus 18.25. And the last thing we're going to do, and then the last thing we have to do is distribute this 2 in. We're going to multiply it by the x plus 4.5 squared. And remember, we can't multiply it in because the order of operations says that we'd have to do the exponent first. It's just going to sit in front, but we're going to multiply it by that. And then we're also going to multiply it by the negative 18.25. And when we do that, we get f of x equals 2 times x plus 4.5 squared minus, oh geez, I have to do this in my head, don't I? 36.5. And so that means our vertex would be at negative 4.5 and negative 36.5. And that's it. You are done.